Okay, let's repeat that. The condition that we use in if statement usually, but not usually, but just must have two possible outcomes, yes or no. So just two possible alternatives. Truly speaking, not two, but not greater than two, because when we use this short version of if, we use only one alternative that corresponds to yes, or when this condition is true. But in some, well, and generally speaking, it's enough to implement any possible selection between any number of alternatives. We can do it using nested selective structure. If inside if, and after that we can use one more if inside this if, and so on. But this construction is not very readable, and in some cases it's better to use the statement switch that allows us to select one alternative among several ones. The general form of the switch statement is written here. Switch is a keyword. Case is case, default, and break are also keywords, reserved words. It means that we can use it only in predefined sense, only in switch statement. You cannot create a variable with name case or switch or break. It will be a mistake. Well, in this general statement, the item expr is an expression, value of which determines the variant to be selected. These identifiers const1, const2, and so on, const n, are integer valued constants. Statement number 1, statement number 2, and so on, statement number n, and statement def are competitive statements, one of which is selected for execution. And usually after the statement, it should be written we should write a keyword break, but it's optional and we consider the features of using break on example in Visual Studio. The branch default may be omitted. And the scheme of execution of the switch statement is as follows. First of all, the value of expression is calculated. After that, this value is compared with their constants, number 1, number 2, number n, and so on, one after another. And if the value of expression and value of some constants are the same, in this case, this branch is selected for execution. And If this branch is ended with the break statement, then the switch completes its execution. Usually each branch should be ended with break. If break is absent, the next branch is executed and so on, up to the first break or the last alternative. If the value of the expression doesn't coincide with any constants, then the branch default is selected for execution. And if the default variant is omitted, then switch does nothing. Well, let's consider some example of using switch. Suppose I want to print, I have a integer variable that corresponds to the mark on exam, 5, 4, 3, or 2. And I want to output the result of exam in verbal form. Excellent, good, satisfactory, poor, or wrong mark. This switch solves this problem. Let me copy just from this presentation these a few lines here in Visual Studio. Let's declare the variable test result. Example 4. Or of course it should be written in another type of quotas. Not as a presentation. Okay. And okay, the example is ready. Let's check it. As you see, the result is 4. And in this case, we, oops. In this case, we will see on the screen the line good. If I change the value to 5, we will see the result excellent. If I write here some value that doesn't coincide with any constant, 5, 4, 3, 2, we see the line wrong mark. Well, this is a typical way of using switch and case. Now let me show some features of switching case. First of all, here I can write in general an expression. The trivial expression can be just an identifier of a variable, test result. But in general, I can write here any expression like this. What we will see on the screen now? Poor, because the result of the expression is 2, and we will see the line that corresponds to case 2. Okay, maybe you can say that you can compute the value of this expression before, but in some cases it will be useful to compute the expression just inside switch. Okay. Now the result of the expression is outside of these marks, and we will see the line run mark. Okay, so this is the first feature of switch. Next feature. I just rewrite these the switch on another style, when all of the statements that corresponds to some branch is written one after another. You see that here the branch that corresponds to 5 consists of 2 statements. One statement is an output statement, and the second statement is a break. And the same can be said for any other branch in this example. The output statement and the break statement. What happens if we remove all the breaks? Suppose that I forget to write all the breaks and I write only output statements, and test result equals to 4. What will we see on the screen in this case?
Good, satisfactory, and poor.
And run mark to.
Yes, or run mark, yes.
Well, if you don't write breaks, switch works as follows. It selects the first alternative that corresponds to this the value of this expression, and executes all of their statements up to the end of the switch. And we see all of the lines here. Up to the end of the switch, or up to the first break. If I write break, just one break here, and the test result equals to 4, we will see on the screen good and satisfactory up to the first break. And if the result is 2, for example, we will see poor and wrong mark. In some cases, just in a few cases, we write switch without breaks. In 99.9% of cases, it should be written with break. So the general rule is don't forget to write the break inside switch. This is the next feature of switch. Don't forget to write the break. Well, and the next feature of switch. Maybe switch and case is just maybe the one of the statements in C, the one of the cases in C language, when several statements can be written without figure braces. If you remember, no, not if, but as you remember, in the if statement, for example, if I want to write some, and if I want to write several statements inside if, I must write these figure brackets. But in switch, these figure brackets are optional. You can write it or you can skip it. The result of the execution of switch and case will be the same. You can write here any number of statements. For example, let's write just excellent several times. You can write it any number of statements and it will be okay. Let's assign to 5 and we see excellent several times. Well, if the switch contains their default branch, this branch will execute it when the value of this expression doesn't coincide with any alternatives. For example, 10. In this case, we will see wrong mark. But if their default branch is omitted, their switch does nothing if the value of expression doesn't correspond to the value of these alternatives. So you will see that switch does nothing. Okay, let's assign 3. That corresponds to satisfactory. And the next feature of switch is that here in case I can write only constants or constant expressions. For example, this 3 is a unnamed constant. It's just 3 written in program. But I can write here also constant expression. For example, 2 plus 1. Compiler computes the value of this expression, and it will be 3. And the result will be the same. Or I can write it here, 1 plus 1 plus 1. It's hard to compute in mind. 1 plus 1 plus 1. Let computer do it. It will be 3 again, and we will see it's satisfactory. Well, not only constants, but constant expression can be written here. And here I can use also unnamed constant. For example, I can declare, sorry, not only unnamed, but also named constant. Constant alternative number 1 equals to 5. And I can use the identifier alt1 here to indicate the alternative number 1. And also it will be okay if I assign here 5. We will see on the screen, excellent. But pay attention, you can use here only constants. If I remove const, alt1 becomes a variable, and I cannot use variables here for alternatives. Only constants, named or unnamed, or constant expressions. For example, -2 plus 2. It's a constant expression that includes also named and unnamed constants. Well, and maybe the last feature of switch. As expressions and constants, I can use only integer value types. I cannot use real value types or strings. For example, if I type here real number, even this real number equals to integer number, it will be a mistake. If you try to compile your program, there compiler, it's truncated the integer part, but here you see that Visual Studio shows you this mistake, that you use double instead of int. And if you try to use here double, yeah, you see also that Visual Studio underlines this value with a red line. It means that you cannot use any value of the type double here. Only int. Only integer value types can be used here. This is some restriction of switch. If you should select one alternative using real numbers, in this case you must use if and else. Switch is not applicable here. Well, this is, I think, all of the features of switch that I want to discuss with you. Do you have any questions?
No, sir.
No, sir.
If you will have some questions, you can type it in chat during the lesson, or you can ask me using microphones. Okay. Yes, so only integer num is inside case. Yes, here, I repeat that here I can use only integer numbers, but of course in this statement I can use any numbers that I want. For example, double, float, string, any numbers. Or, sorry. It must be declared outside, but I can use it here. Why we write default? Again, let me repeat that the default branch is executed when, let me write here the default branch. Suppose that test result equals to 10. The value of this expression equals to 10. 10 is not coincide with this value, this, and so on. It doesn't correspond to any branch. In this case, the default branch is executed. So this branch is executed when the value of the expression doesn't correspond to any alternative. In this example, we will see on the screen the line run mark, but in your programs, you should write here any other expression. If, according to your program, you should skip this action, the default branch can be skipped. You can delete it. Well, any other questions about switching case? Well, no questions in chat, no questions by microphone. Okay. Well, I already said that if we should write several statements inside one branch, you can write it as a sequential structure, but it's not obligatory. Also, you can use nested structures like if inside switch, or even switch inside switch, but it depends on the problem that you solve. For example, here you can write if statement. If, for example, test result, I don't know, any condition, and something here. Well, you can write if inside case, or you can write even nested switches, switch inside switch, and so on. It depends on the problem that you solve. Well, if you don't have any questions, let's move to the next slide of my presentation. And let's discuss about loops. Of course, you will use loops on practice. You will solve a lot of tasks with loops already. It's very good. But here we consider it from the theoretical point of view. We discuss about some features of loops. In general, I can say that loop or cycle is a computational structure for repetition of a statement or groups of statements several times. The repeated group of statements is called loop body. It can consist of one statement or several statements. And in the last case, when we should repeat several statements, the loop body must be organized as a composed statement. So this sequence of simple statements should be enclosed in figure brackets. The principal peculiarity of loop is back off to the beginning of the body for its repetition. So loop jump backwards in general computational structure of the algorithm. And of course, to organizing their number of repetition, it's required to undertake some additional efforts. First, any loop includes as its part a condition of loop termination, which is checked at every iteration, and on the result of which further action depends. One of the results of checking this condition leads to return to the beginning of the loop body. And other result completes the loop execution and transfers control to the statement being after the loop. Well, again, one of the first features is so-called loop termination condition. And secondly, usually in loop organization, one or more variables are used, which are called control variables or loop counters. Their destination is to participate in loop termination condition. And in order to provide such functions of control variables, we must initialize them before loop and change their values inside it. So include in the loop body some operation of changing the values of control variables. Well, these two features are very important. Every loop contains loop condition and a control variable. And according to where the termination condition is placed, the loops may be divided into loops with the precondition, when the condition is placed before loop body, and loops with postcondition, when the condition is placed after loop body. This is a general diagram that corresponds to the loop with precondition. This is a loop condition, and if the loop condition is true, then loop body is executed. And after that, after loop body is completed, we check their condition again. We come back to their loop condition. We check loop condition, and if the loop condition is true, we repeat loop body again, and again, until the loop condition becomes false. If loop condition is false, loop stops its execution and the program is continued. This is a diagram of loop with precondition. Condition is placed before loop body. Here, in this case, the condition is placed after loop body. And this loop is called loop with postcondition. In this case, first loop body is executed, and after that we check condition. If this condition is true, we come back here, execute loop body again, then we check the condition, and if this condition is false, loop is stopped and the program is continued. So here loop condition is placed after loop body, and this loop is called loop with postcondition. Also, in some cases, loop body can be divided into two parts. And in this case, we can say that this loop is a loop with internal termination condition. Here, the first part of the body is placed before loop condition. After loop condition is checked, and if this condition is true, the second part of loop body is executed, and we come back to the first part. And if this condition is false, loop is stopped, and we continue the program execution. These are the three general types of loops according to where the condition is placed: before, after, or inside loop body. And also the loops can be divided into two groups: loops with their known and unknown number of repetitions. In one case, we know exactly how many times the loop should be executed. But sometimes it's impossible to know in advance the number of loop iterations, because it's computed in the course of program execution. And in this case, we usually we can say that one group of loops are loops with their known number of iterations, known number of repetitions, and another loops are loops with unknown number of repetitions. In the C language, there are three types of loop statements. Two of them describe precondition loops, and the third corresponds to the loop with postcondition. And loops of any types may be used for organizing loops with both known and unknown number of repetitions. But the loop for is the most convenient for describing loops with known number of iterations. And this lesson, we discuss about loop for. Again, let me repeat that in generally speaking, loop for can be used to organize both loops with known and unknown number of iterations. But usually in 99% cases, this type of loop is used for loops with known number of repetitions. The general form of loop is written here. Body for is a statement that contains loop body. Expression number 1, expression number 2, and expression number 3 are some expressions. And the meaning of these expressions are as follows. Expression number 1 provides for operations of loop initialization. It's computed only once, when the loop is starting. Expression number 2 corresponds to loop termination condition. It is computed before statement body for. And if the value of expression number 2 is false or 0, then the loop is stopped. If the value of the expression number 2 is true or not 0, then loop is continued. And again, in the most cases, 99% of cases, we use a comparison as expression 2. But in general, I can write here any expression, not only comparison. Any logical expression with the result true or false. Expression number 3 is computed at the end of the loop, after all the operations of the statement body, and is used as a rule to change the value of control variables. This diagram corresponds to the loop 4. Expression number 1 executed only once before the main part of loop. Expression number 2 is loop condition. And usually this condition we use it comparison. If this condition is true, then body of loop is executed. And after that, it should be expression. After that, the expression number 3 is executed. Expression number 3 usually is used to change the value of loop counter. After execution of expression number 3, we come back to the expression number 2, the loop condition. We check the loop condition, and if it's yes, if it's true, we repeat loop border again. We execute the expression number 3, come back to loop condition, and so on. If the loop condition is false, the loop is stopped. Well, this is a diagram that corresponds to the loop 4. On this slide, you may see some examples of loop 4, but I think it's better to consider these or similar examples in Visual Studio. Let me open the Visual Studio. And let's write the very simple loop that outputs numbers to the screen. Loop 4 is a keyword, reserved word. After that, I should write statement number 1, and usually here we initialize loop counter. Let's declare a variable I for loop counter, and let's initialize it with 0. I smaller than 10. This is a loop condition. Loop will be repeated if this condition is true. Loop will be stopped if this condition is false. And the statement number 3, the statement that changes the loop counter, I++. Here Let's output just these numbers to the screen. Let's output I to the screen. Very, very simple loop, extremely simple loop. After I run this program, what numbers will we see on the screen? What numbers will be printed?
0 through 9.
From 0 to 9, right. The numbers from 0 to 9.
Don't you need curly braces?
Let's discuss. I say a few words about it, about braces, of course. Well, we see the numbers from 0 to 9. Well, if I change this condition something like this, what will we see on the screen?
0 to 10.
Numbers from 0 to 10. Okay. Well, let me write here one more output statement. For example, like this. Just this output statement. I want to output all of the numbers twice. Who can guess? What will we see on the screen?
It should be 0 to 10 twice. 0 to 10 to 0 to 10.
Oh,
So
0, 0, 1, 1, 2, 2, 3, 3.
0, 0, 1, 1, 2, 2. This answer is wrong. 0, 0, 1, 1.
I think it should just be twice, 0 to 10, and then on the same line, 0 to 10, I think.
No. Also wrong. Any other suggestions? What will we see on the screen in this case?
Oh, you will only see 0 to 10 because once you reach 10, the loop is met its conditions, right?
Yes.
Yeah.
Well, according to this general description of loop, body of loop contains only one statement. Only one statement. It's written here. Only one statement. And only this first statement will be repeated. And the second statement will be executed after loop. And we will see on the screen the numbers 0, 1, 2, 3, 4, 5 up to 11. Why 11? Because the 11 is the last number of I. When I equals to 10, this condition is true and the line number 16 is executed. And after that, I++. And when the value of I is 11, this condition is false. And in this case, the line 17 will be executed. So it's not error, as you write here. It's a good loop. It's a good loop, but it will work like this: 0, 1, 2, 3, 4, 5 up to 11. But when I enclose these two statements in braces, in this case, we will see on the screen 0, 0, 1, 1, 2, 2, and so on. Because this one composed statement will be considered as a loop body. From the point of view of compiler, this is one statement composed. And we will see 0, 0, 1, 1, 2, 2, up to 10. Well, the rule is don't forget to write the braces. Even your loop body consists of one statement. Just write braces to avoid such mistakes. Okay, very good. This is one feature of 4. But let's consider some other features. We start from 0, but what happens if I write here 5? What will be the output of this algorithm?
5, 5, 6, 6 until 10.
Yeah. Sorry. Wait a minute, please. Well, I'm here. I come back. Let's consider some feature. Well, if I assign 5, we will see on the screen 5, 5, 6, 6, 6, 6, and so on. Okay, what happens if I assign here 20?
Then it should do nothing. The loop does nothing. Because I think because it's past the boundaries of the
Meets any of the conditions within the
Yes.
problem.
Yeah, well, the loop will do nothing, because the initial condition, what will be the initial condition? 20 smaller or equals 10. This condition is false from the very beginning. That's why the loop body will be skipped, and we see nothing on the screen. It's correct. It's correct from the point of view of compiler. The compiler outputs you succeeded, but loop body will be executed 0 times. Well, but in this case, what we will see on the screen,
it should keep generating numbers infinitely, right? It just keeps putting numbers.
infinity numbers.
Because
See.
Oh no. Oh no, you don't know.
The condition. Look to the condition. I change the condition.
No, you're right.
Nothing displays because I is
0 is not greater than 10, so nothing.
Yes. Again, their initial condition is wrong. Is false. From the very beginning. I 0 greater than 10. It's also false, and the loop is skipped. Well, okay, let me remove this. Okay, let's start I from 0. Well, usually we write here I++ to increase the value of I 1 by 1. 1 plus 1 plus 1 plus 1 and so on. But in general, I can write here any statement that changes the value of variable I. For example, I plus equals 2. In this case, what will we see on the screen?
2, 4, 6, 8.
Yes, starting from 0, 0, 2, because their initial value is 0, 0, 2, 4, 6, 8. The last number I will be 10. 10 smaller than 10 is false. And again, if I output the I after the loop, the last number here will be 10. The last number outside loop. Okay. Also, I can even write just I, or I can skip I can write here empty statement. What happens in this case?
Infinite zeros, right?
Yes. I skip the statement that changes the value of I. In this case, value of I still be 0. 0, 0, 0, 0, 0. And we see infinity many zeros. The same situation will happen if I change the statement number 3 from I++ to I-. If you remember, I- subtract 1 from their their value. Yes, and
0, -1, -2, so on.
Yes, 0, -1, -2, -3, and so on, infinity many numbers. Because this condition always will be true. Infinity many negative numbers. This mistake is a very, very hard mistake. It's very hard to find such mistake in this program, because compiler compiles this program, you can run it, but this program never ends because you write a wrong condition. You can write wrong condition, or you can write wrong statement that changes loop counter. In both cases, your loop can be endless. Well, very carefully write loop conditions. Okay. And now let me write very simple example. I think you consider this example in practice, but let's discuss about it one more time. How to compute the sum of numbers. We need to introduce the new variable sum, and after that we should increase this sum. We should add to current value of variable sum the value, for example, of loop counter. And after that, I can output to the screen something like sum equals to sum, and we will see on the screen the sum of the numbers from 0 to 9. The sum will be 45. Let's start from 1, because from 1 the result will be the same. Okay. How to compute the product?
Do you have to assign the sum to 0, or can you just declare it?
Well, suppose that I want to compute the product of the numbers. Will it work if I just change plus to star?
Well, it should be it should just keep being, it should be 0, right? Because you started from 0. Oh wait, no, you started from 1.
Right. If I want to compute the sum, the initial value is 0. But if I want to compute the product, the initial value must be 1. This is the product of the numbers from 1 to 10. Okay. This is some very simple examples. I think you already implemented some examples. You solve some problems on practice. But, well, during these lectures, we consider some features. Well, as you see, in some cases, I can skip here the loop expression number 3, but I can write it here. In this case, the loop will work the same. Also, I can skip here the initial statement. But in this case, I must initialize the loop counter before loop. And the result is the same. From the point of view of compiler, I can even skip this. And this program will be correct. If I compile it, compiler outputs success. But this loop will be considered as endless loop also. Empty statement number 1, empty condition, and empty statement number 3. Loop is correct, but it's endless. And in this case, I will see the line product equals to 1 infinity number of times. But again, this is just a feature of loop statement. And of course, you should write here statement that initialized the loop counter, statement that changed loop counter, and statement that computes loop condition. Loop condition must be usually loop condition is just a one comparison, but generally I can write here rather complex logical expression. For example, I smaller than 10 and I greater than 5. In this case, loop body will be executed only if this complex condition is true. And here, when I is 1, the loop is, this condition is false and loop is stopped. Again, usually we write here one comparison, but you can write here only also a very long logical expression. Okay, let's come back to this slide. This slide I already discussed with you. I show you all of these examples, including this empty loop. Well, also we consider these examples as a loop with known number of repetitions. When we change it as a plus plus or plus equals 2, also we consider all of these examples in Visual Studio. Okay. Next week, I think, yes, our time is over. Next week, we'll continue our consideration from this point. Do you have any questions about this?
No, sir.
No, sir.
No questions. Very good. Very good. I stop sharing. I stop recording.